This video now is about simulating the problem in probability. Basically, it's one main thing we got to talk about. The first problem, it sounds a little difficult, and then we'll get a little bit easier. We're just going to work out 3 examples, and then we'll do a lot of examples in class. All right, suppose you take a 3-question multiple choice test. Each question has 4 possible answers. What is the experimental probability? Not the theoretical. Okay, theoretical, we just figure out with numbers. We can figure it out. But when it asks for the experimental probability that you will guess 2 out of 3 correctly. So we have to actually do an experiment to find the experimental probability. And this assumes that you don't know, you're just guessing. You have no idea. There's no other thing. You have each question is equally unknown to you. Okay? So we've got to figure out some kind of situation that would simulate this. We could toss a coin, but a coin just has 2 solutions. We really need something that has 4 possible answers. We could do a dice, but again, that has 6 possible choices. Okay, so one thing you can do when you have 4, or a number that isn't with a tool, we can use, well, first of all, because we want to find the experimental probability, we have to simulate the situation. So getting 1 right out of 4 choices is kind of like a spinner, where you have 4 equal spaces, and 1 would be right, all the other 3 would be wrong. You could use different colors. I just used the letters to help you see it. Okay, so when you land on the right one, that would be the right answer. Okay, you could spin, and so to find the experiment, you want to do a bunch of experiments. So let's say we do 60. You spin it 60 times, and you group the answers in 20 groups of 3, counting the groups with the 2 R spins. So I did a couple here for you. What if you spun it like 3 times and it was RWW? And then it was WWW, and then all these. Okay, so these are 5 solutions right here. And already, just with 5, we just have only 1 that has right and right. Okay, well, you would do 20 groups of those. And whichever how many you had that had 2 R's in them, that would be, it might be maybe 7. 7 might have 2 R's in them. So your experimental probability would be 7 out of 20. Then, of course, to get the percent, you would multiply that by 5, right, to get the 100. Okay, and then 7 times 5 is 35 over 100, and then that would be 35%. So that's just an example of a experimental probability that you could work out, and where you had to simulate the problem. Okay, let's try another one. It might be a little bit easier to understand. Okay, number 2. What is the experimental probability? Again, they're going to ask specifically for the experimental probability. When they ask that, then you have to think of a way to actually simulate it. All right, what is the experimental probability that exactly 3 children in a family of 5 children will be boys? Okay, and you assume that the probability of a girl equals the probability of a boy. Okay, well, we can simulate this by tossing a coin, because we would just need 2 outcomes. So a coin is really good whenever you just need 2 outcomes. We'll assume the head is boy and the tail is a girl. So if you toss it 100 times and you organize it into 20 groups of 5. So you have 5, because that would be the 5 children, and you want to do about 20 of them. Okay, you could do more of them if you wanted. Let's just start with 20. And then you count the number of groups that have 3 heads, or in our case would be 3 boys. So here I did a few of them. I did 5 here. And see right here we have, that only had 2 heads, so that's not going to count. Here I have 3 heads. That's like having 3 boys. That's only 2 boys. This is 3 boys right here. Here's another group of 3 boys. So already out of the first 5 examples of how I tossed it, 3 out of them were boys. And so if you did it like, we could multiply this by 4, we get 12 out of 20, but it might be much better if you could go ahead and do the actual 20 times and see if you got that many. Okay, and then you would just get your answer, then make it into a percent. All right, one more example, one last example. Supposing you have 4 pairs of shoes to choose from each day, but you have a very special pair, and you want to find the experimental probability of choosing your favorite pair of shoes, your favorite pair of shoes at random. Okay, remember, experimental probability. So what simulation would you choose? Would you toss a coin, dice, chips from a bag with 5 different colors, or a spinner with 4 equal sections? I think it's pretty clear. You wouldn't do the coin because that's only 2 choices. The dice is going to be 6, and you have only 4 pairs. You wouldn't do 4. You don't do the thing with 5 colors because you need 4. So this would be the one that you'd have to pick. You'd have to have the 4 equal sections, just like the first problem, or the first problem that we did. Okay, so we're going to do more of these and experiment around a lot in class, and I think you'll be able to understand it better.